Welcome dear grade 9 students. Here we are again with trigonometric relations. It's a totally new chapter, but I guess you have an idea about these words: sine, cosine, tangent, cotangent. You see them on the calculator, and you may see them on the copybooks of students and your friends in the secondary stages. So here are some notations that you are going to see in this chapter, and let's get started to know more and more about these words. Part 1 of this chapter is related to trigonometric relations in a right triangle. So, trigonometry in a right triangle. Here is a right triangle ABC. Here it is right at A. Okay, here is the right angle A. And here is the hypotenuse BC, and here is the side AB and another side AC. Notice that I named this angle alpha. Now we are going to talk about the sine, the cosine, the tangent, and the cotangent of this angle alpha, this acute angle alpha. Now, sine, cosine, tangent and cotangent are called the trigonometric relations or the trigonometric functions of this angle alpha. Let's start. Here are the rules that are related to these words: sine of alpha. So the sine of the angle alpha is equal to the opposite side of alpha. What's the opposite side to alpha? It is AB over the hypotenuse. In grade 10, you are going to know where did these rules come from. Now, all what you are responsible about is the rule. Okay, you have to know the rule. And later, inshallah, you're going to know where did it come from. So, again, sine alpha, this is the rule for sine alpha. It is equal to the opposite, the measurement of the opposite side, which is here. AB, what do I mean by opposite side? It's the side facing the angle I'm talking about, over the hypotenuse. And here is the hypotenuse, which is, as you know, the longest side in any right triangle. So if I'm going to substitute the sides, it is AB over BC. And whenever I have numbers, I can just substitute numbers and get the answer. Okay? Now, what about cosine alpha? Also, there is a rule for cosine of the angle alpha. So, cosine of the angle alpha is equal to the measurement of the adjacent side to alpha. Look at this side. This is the adjacent side to alpha over the hypotenuse again. Some may tell me, okay, this is also an adjacent side, but when I say the adjacent side to alpha, I mean the adjacent side other than the hypotenuse. So, we take this side, which is adjacent to alpha, okay, which is AC, and this is the hypotenuse. We divide them and we will get the answer. If we have numbers, we can simply evaluate and get the answer. Now, what about tangent alpha? The rule of tangent alpha is that it's equal to the measurement of the opposite side divided by the measurement of the adjacent side. Well, this rule comes from another rule that says tangent alpha is equal to sine alpha over cosine alpha. So, if you divide sine alpha, which is this value, over cosine alpha, which is adjacent, over hypotenuse, look what will you get? You can cancel this with this and you will get opposite over adjacent. So, another rule for tangent is that it's equal also to sine of the angle alpha over the cosine of the angle alpha. Okay? Now referring to this triangle, then tangent alpha is equal to the measurement of the opposite side, which is AB, and over the measurement of the adjacent side, which is here AC. Now, when do we use this? Suppose the question was to find sine alpha, then cosine alpha, and then to deduce tangent alpha. So when there is a deduce in the question, then definitely you are going to use the previous parts and you are going to divide sine alpha over cosine alpha without applying this rule. Okay? Now let's talk about the final trigonometric relation, which is cotangent of alpha. Cotangent of alpha is actually the reciprocal of tangent alpha. So it is 1 over tangent alpha, then definitely it is adjacent over opposite. So cotangent alpha is the measurement of the adjacent side to alpha, which is here AC, over the opposite side of alpha, and definitely it is also equal to cosine alpha over sine alpha. Okay? Now, these are the rules related to trigonometric functions in a right triangle. Now, let's continue our presentation and have some training exercises to get more confident about these rules. Training exercise 1. Here is a right triangle ABC. It's right at A. This side is AB, this side is AC. This is 4 centimeters or 4 units, and this is AC, that's equal to 3. Who can tell me how much is BC? What's the measurement is the side BC? It is, using Pythagoras, it is BC squared is equal to AB squared, which is 4 squared, plus AC squared, which is 3 squared. Hence, it's equal to 16 plus 9, which is 25, and thus BC is equal to radical 25, which is 5. And you know, this is the most famous right triangle. It is having the sides 3, the shorter one, then the middle one is 4, and the longest one is 5. So this is the famous right triangle that has sides 3, 4, 5. And here is the right angle A. Now, so we calculated the hypotenuse BC because surely we are going to use it. The question is, of course, to calculate sine alpha, cosine alpha, tangent alpha, and cotangent alpha, referring to these values. Now, let's apply the rule I talked about in the previous slide. Sine alpha is opposite over hypotenuse, thus it's AB over BC. So AB is 4 over the hypotenuse BC, which is 5. And the answer is 4 over 5. You can change it into a decimal number, and it is 0.8. But it's no problem to keep it in the fractional form. Again, cosine alpha is adjacent over hypotenuse, then it is AC over the hypotenuse BC, and thus it is 3 over 5. Again, tangent alpha, it's equal to the opposite over the adjacent, thus it's equal to AB over AC, which is 4 over 3. And finally, cotangent alpha, it's definitely the reciprocal or the inverse of tangent alpha, thus it is 3 over 4. Now I want you to notice something. What do you notice? Sine and cosine are never greater than 1. And the answer is that, or the secret is that, in a right triangle, the longest side is the hypotenuse. And whenever you are dividing by the longest side, you will never get a value that's greater than 1, because definitely the numerator here must be less than the denominator. And whenever you have that the numerator is less than the denominator, you will never get a value that is greater than 1. So this is a note to keep in mind, that sine and cosine are values without units that are never greater than 1. And now, later, we are going to talk about this issue, inshallah. While tangent may be greater than 1, because I'm not sure if I'm dividing the larger side over the smaller side, or vice versa. But in the sine and the cosine rules, I'm sure that I'm dividing by the hypotenuse, and the hypotenuse is the longest side, so I will never get a value that is greater than 1.